everybody, we are moving on to another type of proof, which is called a coordinate proof. And this is one that you don't use given information, but you actually calculate things to show that they are true. So for instance, you're going to calculate the distance of two things to show that they're equal. And we're going to go over an example of that. What you want to say to yourself, your mantra for coordinate proofs are distances, slope, sentence. That's what you want. You want all the slopes, all the distances, and all the sentence. Here's what the sentences are. So you're going to want to have this handy, but to prove that lines are parallel, we need to know that they have the same slope. So that's where that slope part comes into play. And to prove that they're perpendicular, we need to show that the slopes are negative reciprocals. These two facts go all the way back to chapter 1, but you pretty much count your slope and you say, hey, they're the same, or they're the flipped version and one's positive, one's negative, as a reminder of what negative reciprocal means. Then we move into actually identifying the quadrilateral, and here is where all those properties we've been using come into play. So to prove it's a parallelogram, by finding all the distances and all the slopes, you're going to be able to say that you have two pairs of opposite sides that are both parallel because they have the same slope and congruent because they have the same distance. For a rectangle, you're going to say the exact same thing as a parallelogram because you first have to identify it as a parallelogram. And then you're going to say that the consecutive sides are perpendicular. And you might be saying, well, but it has 4 right angles. That's what the word perpendicular is giving us here. We're using the fact that they're perpendicular from the slope to get us those right angles. So we're using that property. A rhombus, again, you're going to start by stating it's a parallelogram because we need that first. And then you're going to say that it has all 4 sides are congruent. For a square, you're going to combine these two. So you're basically going to say everything about a parallelogram, then you're going to say it has consecutive sides that are perpendicular and all 4 sides are congruent. And that's why it's a square, because a square's got all of it. A trapezoid, you're going to simply state that it has 1 pair of opposite sides that are parallel. And anytime the word isosceles or equilateral comes up, no matter what the shape is, you're simply going to say that it has 2 equal sides if it's isosceles and 3 equal sides if it's an equilateral triangle. If it was an equilateral quadrilateral, well, that's a square or a rhombus, right? So you'd be using that. But basically, you just want to state how many things it has that are equal. If it ever says prove that something isn't whatever shape. So let's say it says prove it isn't a rectangle. You're going to go up to the rectangle and you're simply going to say it doesn't have consecutive sides that are perpendicular. So you would go and say the opposite of this statement. Okay, so let's do an example together. Now, remember, we need slopes, we need distance, and we need a sentence. So I'm going to start by graphing the quadrilateral they gave me. So there are all the coordinates graphed. And then I need to, first, I recommend doing the slope first because it's going to make your distance formula faster. So I'm going to count the slope by doing rise over run. So this is up 5 and to the left 3. So it's going to be a negative 5 over 3. Remember with slope, it doesn't matter where the negative is as long as it's only 1. And then I'm going to find the slope of the other sides, which, oops, sorry, I'm hitting too many buttons too quickly. So I'm going to find the slope of the other side, and that's up 6 and to the right 10. So I have up 6 and to the right 10. Now the next piece of information you're seeing here on both is me calculating the distance. What you want to remember is that distance is just like the Pythagorean theorem. So if you're looking here and you have this right triangle that's being created with AT as the hypotenuse, remember a squared plus b squared equals c squared. That is the distance formula. It just has the square root already attached to it to find the answer. So all I'm doing is substituting those values in for a and b. So 6 squared plus 10 squared, that's 136. So I get the square root of 136 for both of those values. Again, I'm just calculating distance. And then up here, I'm getting 6 because 25 plus 9 is 36. The square root of 36 is 6. And then I'm going to finish this with my statement. So going from that cheat sheet, I'm going to say that it's a parallelogram because both pairs of opposite sides are parallel and congruent. It's a rectangle because consecutive sides are perpendicular. And if you don't remember, 6 over 10 reduces to 3 over 5. So that is the negative reciprocal of negative 5 over 3. Because one's positive, one's negative, and one is the flipped version of the other. And that's how you do a coordinate proof. We're going to practice these together, but I just wanted to show you what it looks like. Have a great day.